Hello and welcome to this Things I've Learned This Week video. If you don't know the concept of the channel, maybe refer to the introduction video I should have uploaded by now. But for us here, we're gonna just jump into it. So I came across a few things that I thought I understood in coding overall and in Python, but I realized that when I could use them or make my life easier by using them, I wasn't thinking about them because it wasn't that natural to me. So I'm going to try and make it more natural and more logical for me as I'm going to share it with you. Starting with slicing. Slicing is one of the most basic methods you go through when you're learning about Python's lists and strings management, but actually you can be very smart with it most of the times, and this is what we're going to go through here. So first statement is just a little reminder on slicing. 3 different parameters, the first one being where you start to iterate in your list, so here index 1 being the 2, where you're going to stop 4, so 1, 2, 3, 4 not included, so we're just getting those, with a step of 1, which means that we're going to iterate through every object. If I print this, then we get 2, 3, and 4 just like we wanted. But a lot of the times what's really interesting is that you can use any of those individually, and especially the last one, the step. And if you use the step with a -1 value, you iterate through your list backwards, which means that you're able to create a new list that's the opposite of the first one, maybe because you wanted a decreasing order instead of an ascending order in your list, or maybe because you wanted to do some calculation in that way. Super useful. Not forgetting that you can use a -2, -3, or any kind of step to just go for every other value backwards too, so 120, 4, and 2 here in that statement. Going into another basic concept, but that I didn't realize was that useful before I was starting like coding for algorithms and problem solving, is sets. Sets are great. Sets have 2 really important abilities. The first one is that sets only have unique values, which is a game changer for a lot of problems that you might come across. And basically the first one would be that just printing or creating an object which is the set of another list is going to create a set of unique values of that list. So you're filtering the double or triple values just like that, which is already really useful. In addition to that, you can make calculations and create new lists, iterate through them, do complicated list comprehension calculations with just a set of some list that you're doing, to be sure that you don't iterate through multiple similar values. Why are sets so useful and fast? Well, it's also because a set is basically kind of a dictionary of only keys. So compared to a basic array, it is way faster to find a single value in your set, because Python is gonna associate it to an index, and that is itself, so it's a key. It's faster, it's more efficient, less time and space complexity if you're using a set. So for a lot of values, it's gonna be way more efficient. That's what I get from what I've read about this subject. Then, obviously you might want to add or remove values from a set. Not going too deep into that, but I wanted to remember that if you add something, you add the exact object that you're implementing. So if you're adding 200, then you're adding 200, but if you're adding a tuple or a list, you're adding the tuple or the list itself. If you wanted to add every value inside of your tuple, inside of your list, inside of anything, you don't have to go into a for loop or anything. You just implement them with an update method and you get the unique values in your set. Obviously, no duplicates. Operations you can do with sets haven't been useful for me yet, but I felt like it was really interesting to go through. So obviously, if I create a set of n and m, which is just basic stuff, 1, 2, 3, 2, 3, 4, I can go through a union. A union here is going to be just the two sets together, still keeping unique values only, so 1, 2, 3, 4. If I went through an AND statement though, this keyword, not keyword, operator, is going to return only what's common between those two sets. So here, 2 and 3. The minus statement, though, the minus object, is going to be a little more complicated because the order is more important here. You're going to remove the values included in M from N. So here 1 is left because, well, 2 and 3 are included in M. If you were to inverse that statement, you would have this set minus the values in this one, so just 4. And to finish with those sets abilities, the little hat thingy is just the opposite of the intersection, meaning that you're going to have the values that are unique to each set individually without the matching values, so 1 and 4. Okay, and here the most interesting part for me actually is, so I discovered that with OR, but I think it's more relevant with when you consider it with most of the keywords in Python. So obviously you know that if you do an if statement saying like if this or this equals that or is true or anything, you're gonna have a very simple way of doing an if statement. But you can also use that as a way of filtering or choosing what you return from a function, what you attribute to an object or anything. So here, if you're using OR in this statement, what you're going to say to Python is x is equal to 0. 0 is a false Boolean value, so my OR keyword here is not going to agree with that. It's going to be like no, so we're going to the next one. The next one is a true Boolean value, so okay, x is equal to 2. So what OR is going to do here is from left to right give the value of the first true statement of the list of choices. So here for the z, if the first object, the first value is 4, well then z is equal to 4. Simple as that. Boom. 2 and 4. So what does that mean? It means that you can do a verification, go through multiple answers, multiple solutions without doing an if statement or any kind of control. You just use OR and you attribute the first value that's not 0. It's a good way to return any kind of value or any kind of statement from, I don't know, a recursive algorithm, for example. That's why I added this little a statement here, so a equal 2 minus 1 or z more than x. Why? Because, well, this for Python is just a false. 2 is not inferior to 1, so it's a false statement. So my OR object here, my OR keyword, is going to say no. This is the next one. Next one is z more than x, which is true because remember 2 and 4. So my a is not be equal to 4 or anything. It's gonna be equal to true. So that's great. If you wanna just check out that multiple conditions, multiple things are not wrong, if at least one is true, you're gonna return a value of true. And this is the real strength of this way of thinking of and organizing that I didn't have in mind at all. Just to be clear though, an OR statement with only 0 is going to come out with a 0. You're not filtering the false values, you're just iterating through every possibilities that you give the OR keyword. And finally, the concepts of lists in Pythons. I realized that they are really close to what we could call a LIFO, so a last in first out kind of list, meaning that with the pop method of the lists in Python, you could just obtain, boom, the last value of your list, so the last in, and remove it at the same time. So what you're going to do is just return the value and remove it from your stack. Very interesting when you're doing algorithms, obviously. But what you have to realize is that they are not really designed for this, and so apparently even if pop itself is pretty efficient when you want to remove the last one, using the parameters in pop like pop0 to remove, pop0 to remove a10 instead of a7 is going to be very inefficient on large arrays and might cause problems in time or spec complexity, I'm not sure anymore. But I searched for more interesting systems that you could have in Python, and I just found out about the collections library. So you could import this DQ method to create an object DQ, which is just a new kind of list that was optimized to be a queue in Python. So creating my object roads underscore queue, which is a DQ object of my list road, and now I can use a method called pop left or pop right for that matter, and do that operations of removing a6 at the beginning of my list and have a new DQ list that is shorter. So I haven't used that much, but I hope it's gonna be useful for you too. Cheers, see you later.